Alright, so you can use this video right here to substitute for the lecture on section 7.5. So in 7.5, this is what we're going to be concerned with: multiplying radical expressions. We've already done something similar to this. As I said, these sections overlap, so at this point it might be a little bit of a review on multiplying radical expressions. And two, we're going to rationalize denominators with one radical term. We talked about this a little bit already in the last class that we had. But we're going to go into more detail, I suppose. And then third, we're going to rationalize denominators with binomials involving radicals. So we really haven't gotten into that. So we'll spend a little bit more time on that. Okay, so let's look at this first slide with these two problems. So basically, we're going to distribute that square root of 11 across that binomial. Now, I'm not a real big fan of the way that this is presented, but notice that because it almost implies that the 5 is multiplying by the 11, which is a radicand. That's not exactly what's happening. But in the distribution to the right, we've got square root of 11 times square root of 2. That's going to involve the product rule. Remember, the product rule when we multiply two radicals is that we multiply what is underneath the radical, which is the radicand. So let's go ahead and look at the next step. So we get 5 square roots of 11 minus square root of 22. See, there was a multiplication of the two radicands, which was the product rule. And remember, we can't combine these any further because they don't have the same radicand. So just so happens to be, as not so pretty as that looks, that is already simplified. So now we're looking at part B, where we're going to get a distribution of that 7 across those two radicals there. Alright, let's go ahead and look at the next step. So there's the distribution of 7 across that binomial. Then here we have our next step. So this is what we've been talking about a lot so far, even going back to the class last week, is simplifying these radical expressions, where we look for a perfect square factor. So notice that 54 becomes 9 times 6, and notice that 24 becomes 4 times 6. Notice in the blue here is that perfect square factor. So let's go ahead and look at the next step here. So what they did was take the square root of 9, which is 3, and 3 times 7 yielded 21. And then in the other radical on the right, they took the square root of 4, which is 2, so 2 times 7 is 14. Now we have a situation where we do have two radicands of equal value, so we can combine those further. So here's our next result. 21 square roots of 6 minus 14 square roots of 6 yields 7 square roots of 6. So now we're going to look at rationalizing denominators with one radical term. So remember from our rules from last week, remember you can't have a radical in the denominator. So what we're doing is rationalizing the denominator, turning that denominator into a rational number. So as it says, the common way of standardizing this form of radical expression is to have the denominator contain no radicals. So this is called rationalizing the denominator. And if you remember from last time, we multiplied by a form of 1. So notice a here has a radical in the denominator. So what we're going to do is multiply the numerator and the denominator by the denominator. And this is the same thing as multiplying by 1. So notice we're multiplying the numerator and the denominator both times the square root of 11. So what we're going to end up with in the numerator is 5 square roots of 11, and in the denominator just 11, because the square root of 11 times the square root of 11 is 11, or square root of 11 times the square root of 11 is the square root of 121, which is 11. Notice that now the denominator is a rational number, where in the previous example at 5 over square root of 11 the denominator was irrational. So this is why it's called rationalizing the denominator. So now let's look at b. So we're going to multiply the numerator and the denominator by what is in the denominator, which is square root of 5. And remember, this is the same thing as multiplying by some form of 1. So using the product rule in the numerator, that's going to give us 5 square roots of 30 over the square root of 5. We just rationalize the denominator. And notice that that 5 is going to cancel out. So our end result is square root of 30. So you can see why rationalizing the denominator is considered important by mathematicians, because that looks a lot neater than this original form we had, where we had 5 square roots of 6 over square root of 5. Square root of 30 looks a lot neater than that. So here we have another example. But they're going to do a little work in that denominator. We're going to simplify that denominator. So remember, we're looking for a perfect square factor, and that 9 times 2 is the same thing as square root of 18. Or square root of 9 times 2 is the same thing as square root of 18. So we're going to take the square root of 9, and we're going to get 3 square roots of 2 in the denominator. So now we multiply by the radical, or the irrational number that's in the denominator, which is square root of 2. So we multiply the numerator and denominator by square root of 2, and so what we're going to end up with here is this right here. So if you look, what happened in that denominator was, numerator seems pretty simple, but in the denominator we're taking the square root of 2 times the square root of 2, which is 2, right? So 3 times 2 yields 6. Now I think we're just going to reduce that fraction to negative 4 thirds times the square root of 2. Now we're going to look at rationalized denominators with binomials. Now this gets a little tricky here. Okay, so now we're looking at rationalizing denominators with binomials involving radicals. So if we look here, we have a binomial in the denominator that contains a radical. So the first step in rationalizing the denominator of these things is to first determine the conjugate of the denominator. So for example, the conjugate of 1 plus the square root of 2 is 1 minus the square root of 2. I like to say that basically the operator in the binomial is changing sign. Okay, in general, x plus y and y minus x are conjugates. So that's the first step in rationalizing the denominator of, in a situation where you have a binomial containing a radical in the denominator. So here it describes the process. So now that we've identified that conjugate, we're going to use that conjugate to multiply both the numerator and the denominator by the conjugate of the denominator. So going back to this example here, we determined that the conjugate of this was 1 minus the square root of 2, so to rationalize this, we would multiply the numerator and the denominator by this conjugate, 1 minus the square root of 2. So they don't use that example, but we're going to go ahead and look at what example they do use here. Okay, so we're going to rationalize the denominator here. Alright, so let's jump ahead to the next step here. Notice in blue we have 2 plus the square root of 3. That is the conjugate of that denominator, 2 minus the square root of 3. So first step obviously is to determine the conjugate. Remember I said the operator basically changes its sign. So here we are multiplying the numerator and the denominator times the conjugate. So what happens in that denominator is something kind of special. Let's take a look at that. So we just want to take a quick look at what is happening in that denominator. So remember, we're using FOIL here. First, outer, inner, and last. So we're just going to move that up a little bit so we have room to deal with this. So we're using FOIL here. So 2 times 2 is 4, plus 2 times the square root of 3, minus 2 square roots of 3, minus square root of 3 times square root of 3, which is 3. Notice the magic that is occurring in the middle part. Those middle terms here cancel out. So what we're left with here is 4 minus 3, which is what they have in the slide there. So that's what's happening in the denominator. So basically the denominator went from being an irrational number to a rational number, 4 minus 3, which is 1. So now the last thing to do is simply distribute that 4 across that binomial there. 4 times 2 is 8, and 4 times the square root of 3 is 4 square roots of 3. So now let's go ahead and take a look at some of the homework problems. Okay, so this problem says to multiply then simplify. But actually, it's much easier to simplify these radicals first and then go ahead with the multiplication. So I would say do it the easiest way possible. Alright, so we have 4. Now that square root of 108 we dealt with before, finding the perfect square factor. And remember, it was 36 times 3. And then now we're going to have to deal with 75. So the perfect square of the factor that comes to mind right off the bat is 25. 25 times 3 yields 75. So we'll bring this down here, take the square root of 36, we get 6 square roots of 3, minus, take the square root of 25, we get 5 square roots of 3. So now we do the subtraction in here, so we get 4 times 6 square roots of 3 minus 5 square roots of 3 is square root of 3, 1 square root of 3, which equals out to 4 square roots of 3. Alright, so notice this is asking me to rationalize the denominator. So rationalizing the denominator simply means that we multiply the numerator and denominator by the radical that is in the denominator. So what we have there is the square root of 3 over the square root of 3 times that expression there. And in a numerator we use the product rule. Square root of 7 times square root of 3 is square root of 21. And in a denominator, square root of 3 times square root of 3 is 3. So here we have a similar situation where we're asked to rationalize the denominator. So remember, that simply means we multiply the numerator and the denominator times the radical that is in the denominator. So using the product rule, we're going to get in the numerator 10 square roots of 14, and square root of 2 times square root of 2 is 2. Now we divide 10 by 2 and we get 5 square roots of 14, and that is simplified. Okay, so again we are rationalizing the denominator. The only difference really here is notice that we have a binomial in the denominator. So let's just go ahead and rewrite this down here. So first off, we have to identify what the conjugate is. Remember, we multiply the numerator and denominator times the conjugate of the denominator. And the conjugate of the denominator is square root of m minus 3. Alright, so now you may be tempted to FOIL the numerator. Let me just give you a little hint on this problem. Don't do that just yet. So just keep the numerator in this form right here, because we're going to see something that happens in the denominator. So remember, we're using FOIL in that denominator. So square root of m times square root of m is m. And remember that magic that I was talking about that happens in the inner terms? So we're concerned with the outer. We get negative 3 square roots of m. And then on the inner we get positive 3 square roots of m. And then the last we get 3 times negative 3 gives us 9. So what's happening here is these inner terms are canceling out. So that leaves us with m minus 9 square root of m minus 3 in the numerator. And it leaves us with m minus 9 in the denominator. So do you see what's happening here? M minus 9 cancels out. So what we're left with here is the square root of m minus 3 as our final answer.